So in this program, I wanted to create a mental math calculation game with various levels of difficulty that adapted to the user. So the idea was that I I wanted the program to choose the difficulty level for you based on your previous scores. So of course this required to implement the game in itself, but also to keep track of the results and make the program behave based on those results. So to do that, I used five libraries mainly. The sys library, which allows the user to quit the program at some point. The time library, which I mainly used to implement a timer. The random library, which I used to randomly choose the numbers and operations I wanted the user to perform. The operator library, which allowed me to convert the operation characters I chose into actual operators. So more on that in a couple minutes. And the pandas library, which allowed me to keep track of the user's results in data frames, which I then stored and read as CSVs. So here, of course, I defined some key variables such as the duration, which is set at 30 seconds for the purpose of this demonstration, and a number of functions to attribute points to the user based on time and correctness. Function here to define the level based on previous results. Functions to choose the operations and numbers randomly. Um, compute, get the question or the equation to display to the user, compute the correct answer, get the user's answer and make sure it's an integer, print some success or failure statements, etc. And of course, a function to display the equations, get the user's answer, um, and compute, print, and return the score in the end. So the main challenges I had to face were first off to to define actually a score computation system that made sense. So that the score would not change too dramatically from one level to another. So say you were level 1 and you had on average 1000 points. Well, I needed a score system that allowed that average to not move too much when you went to level 2. Uh, and of course, we don't want you going from 1000 points to 100 at level 2. That doesn't really make sense. So, defining a good score computation system, and the second challenge was to make the computer understand the operations that I defined. So, this function, I chose the operations based on difficulty level, but I chose them as characters, as you can see. This was easier for the rest of the program to display the questions, etc. But I had to make sure that the computer would understand at some points when I wanted it to compute the correct answer that this was actually the addition operator. So this is why I used the operator library and this very handy dictionary, which just says that this plus sign is actually the addition operator, this is the subtraction operator, and so on. Um, so these were the main challenges, and maybe we can see the program in action very quickly. Um, so if we run it right here in Spider, um, so first it asks for the directory in which the old results were stored. So in this case, it's just the current directory. So I'm just going to press enter. Um, so it asks if we want to play or see our progression or just quit the program. So let's play. Um, so this is the first equation. I'm just going to use my calculator because I've been calculating all day. So let's just do this. Minus 23, minus 164, minus 233, minus 99, and this is minus 135. And the program says the answer is correct. So maybe let's try this one now. Minus 11. Let's try to give it the wrong answer here. So 4. and it says that the answer is not correct, and the correct answer is 151. Time is up. We have 252 points, and now what the program asks where it's going to store the new results file. So let's just keep it in the current directory and press enter, and now we're out of the program. So if we go back, if we take it for another test run just to see the progression maybe, here we go. Then let's just stay in the current directory, type progression. Now we have a graph of our progression, and you can see the 250 point-ish result that we had before. And of course, these results before were just randomly put by me in the data frame. So I guess I kind of aimed pretty high. So please don't mind that. So this is it, and I guess the main limitations of this program are, of course, the aesthetics. As you can see with this graph, I guess we could do something about this axis right here to make the dates and times display better. And also maybe we could create a nice window in which the user can play instead of playing in the console. The second main limitation is the timing. The timer is actually, I didn't implement multi-threading for timing. So if the timer was 60 seconds and you reached a question and there was just 1 second left, well, then you could actually take as long as you want to solve that question because there is no multi-threading. So I guess this should be also solved in a future version of this game.